title of the lesson is Wave Interactions. Vocabulary terms: constructive interference, destructive interference, standing waves, node and antinode, and reflection of waves. Objectives: differentiate between constructive and destructive interference, predict when a reflected wave will be inverted, predict whether specific traveling waves will produce a standing wave, identify nodes and antinodes of a standing wave, and apply the superposition principle. This video is present on YouTube. I'm going to attach the link in the description box of this recorded video so that you can watch it. It shows a real-life application of wave interactions. This device is used to keep silence around a certain region by receiving the sound waves, the noise sound waves, and emitting a similar identical one, such that destructive interference takes place to keep the area or keep the region silent. This is an explanation, a detailed explanation about the application. And starting now with the interference, again, this video is also, the link of this video is also going to be attached in the description box, so you can check it on YouTube. It explains the interference, the constructive and destructive interference. Starting with the constructive interference, consider two pulse waves that are moving in opposite directions. So the two waves pulses are moving towards each other along a stretched rope. As you can see, the amplitude of this wave is, or this pulse, is greater than the amplitude of this pulse. At the moment the two pulses meet, a resultant wave is formed. When the crest of one reaches or meets exactly at the same position with the crest of the other, as you can see, a wave or a pulse of higher amplitude is formed. So the amplitude of the resultant wave is equal to the sum of the amplitudes of each pulse. Now after the two pulses pass by, this one is going to continue its way and the other is going to continue to the right. After the two pulses pass through each other, each pulse retains the shape it had before the two waves met and keeps moving in the same direction. Destructive interference, again, having two pulses moving towards each other along a stretched rope. One is oriented downward, the other is oriented upwards, and they have different amplitudes. At the moment the two pulses meet, a resultant wave is formed. The amplitude when the crest and the trough meet at the same position, as you can see, so this is the crest of the of one of the incident waves or propagating waves or pulses, and this is the trough of the other one. When they meet at the same position, they result in a pulse of lower amplitude than the greater one, because the resultant because the amplitude is the resultant of the difference between the positive and the negative amplitudes of each pulse. And finally, as they pass by, and after the two pulses pass through each other, each pulse retains the shape it had before, and the two waves keep moving in the same direction. They do not reflect. In this case, they do not reflect because there are no boundaries. Now for the destructive interference, there is a special case here, which is complete destructive interference. This happens when a crest and a trough meet and the amplitude of the upward displacement is equal to the amplitude of the downward displacement, so they cancel each other, like as if we have +5 minus 5, it's going to be 0. So this is complete destructive interference. Application on interference for transverse or for circular periodic waves. Here are two sources of disturbances, this one and this one here. They created two different periodic waves that propagate in different orientations. The point is that this is a top view of the waves. So the white ripples represent the crests and the black ripples represent the troughs. So it's actually as such. يعني if we look side view, this is the trough, this is the crest. This is the trough, crest, and so on in all directions. So this is trough, crest, and so on. Okay, so at some point in these directions, we can see that the ripples of the two sources meet at certain positions. Sometimes a white ripple meets with a white ripple, or in other words, a crest meets with a crest, and sometimes a crest meets with a trough, as shown in this case here. This point is the intersection of a white ripple with a black ripple, so it's the intersection of a crest with a trough. And sometimes two troughs meet at the same point, like this point here. I'm going to call this point A, this one B, and the other one C. Okay, so when two crests meet, both are directed upward. This is constructive interference. We add them up. When two troughs meet, like point C, this is constructive interference too, because both waves or both amplitudes are directed downwards, so command also they add up to each other. While for B, when a trough meets with a crest, this is destructive interference, because one will cancel or reduce the other. Interference for longitudinal periodic waves. As you can see, this is a speaker, which is the source of a sound wave that causes the vibration of the particles of the air. At some regions there is compression, which is represented here by this graph represents the variation of the pressure of the air, as we discussed in the first lesson. So the variation of the pressure, this is a pressure, not a displacement. Okay, so you can check it from the first lesson. Pressure as a function of x. Okay, so here this crest represents maximum compression, as you can see, and the trough represents minimum compression in this region. So now we can also represent them if we have two speakers A and B emitting the same sound, identical sounds of the same frequency. The blue ripples here of each one represent the crests. Okay, so the light blue ripple circles represent the crests for sound waves emitted by speaker A, and the dark blue circles represent the crest for the sound waves emitted by the speaker A. Now I'm going to represent the troughs, the ripples that represent the troughs for each one of them. So like for A, this region here is the trough. This is the trough. Okay, this is the trough for the sound waves emitted by A. It must be equidistant for sure from the crest. And similarly for the other one, I'm going to use the green to represent the trough. This is the trough. Must be equidistant, I said. And these are the troughs. You can see that they intersect at some points. They meet at some points. Now again, we need to check if two crests meets, two troughs meet, or a crest and a trough. Let's name 3 points here. If I call this one F, and this one E, and this one K. You can see that F is the intersection of a crest and a trough, of the crest of A and the trough of B. So crest and the trough, this is destructive interference. E is the intersection of two crests, the intersection of two blue ripples, which represent the crests for each speaker. So this is constructive interference. K is the intersection of a crest and a trough. The orange one is the trough and the blue is the crest. So this is destructive interference. And I can also name another point here, L, which is the intersection of two troughs, the yellow and the green ripples. This is also constructive interference because two troughs are both directed in the same, takes the same orientation, or both directed downwards. So positions at which the sound waves interfere destructively are called silent points. Since these two sound waves have the same frequency and same amplitude, if a crest and a trough meet at some position, they are going to completely destruct each other, and thus no sound is going to be heard. These are called silent points.